Everyone says stealth is the only way to survive modern warfare, but they are wrong. While the world chases invisible airframes, Ukraine is using the Swedish Gripen CDL8 link to rewrite the rules of combat. We're revealing why sovereign data control is more lethal than any radar-absorbent coating ever built. What if the secret to defeating a superpower isn't a bigger bomb, but an open-source network? The Gripen CDL8 link is turning Ukraine's fragmented battlefield into a unified multi-domain web that the West's rigid systems can't touch. Discover how electronic agility is outmaneuvering traditional airframe geometry in the ultimate fight for tactical independence. Welcome to the era of the digital guerrilla. By weaponizing Sweden's unique open architecture networking, Ukraine is dismantling closed-source defense paradigms and revolutionizing joint multi-domain operations. This isn't just about a jet, it's about a revolutionary data link that is currently transforming the future of sovereign warfare as we speak. Before we go deeper, take a second to like the video and subscribe.
For decades, stealth was treated almost like a religion in air warfare. The idea was simple: shape the aircraft in a way that reduces its radar cross-section, hide it from enemy sensors, and strike before the opponent even knows what is coming. But Ukraine has exposed a brutal new reality. In a modern battlefield filled with layered radars, passive sensors, drones, electronic listening posts, and data fusion networks, invisibility is no longer just about the physical shape of the aircraft. It is about how much energy you emit, how fast the enemy can connect scattered signals, and how quickly your system can adapt when the radar picture changes. This is where the old stealth argument starts to crack. A low radar cross-section can still be powerful, but it is not magic. Multi-static and passive detection concepts do not always look at the target from one clean angle. They use separated transmitters, receivers, and signals of opportunity to build a wider picture of the sky. That does not mean stealth is dead, but it does mean the battlefield is becoming less friendly to aircraft that rely too heavily on shape alone. Ukraine's war has shown the bigger lesson. Survival depends on integration, software, sensor fusion, and fast decision-making, not only on platform performance. And this is where closed systems face a painful vulnerability. A platform like the F-35 is extremely advanced, but its software, mission systems, and electronic warfare architecture are not something a local operator can casually rewrite for tomorrow morning's threat.
Recent debates around F-35 software sovereignty made one thing clear: modifying such systems independently is not simple, because cryptography, trusted software pipelines, and classified architecture create hard limits on what users can change by themselves. That protects security, but it also creates dependency. The Gripen enters this debate from a different angle. It does not try to win the future by worshipping physical stealth alone. It tries to survive by becoming smarter in the electromagnetic spectrum. Saab describes Gripen E as a fighter built around advanced electronic warfare, real-time data sharing, cross-domain sensor fusion, networked data links, and software adaptability. In simple words, Gripen's strength is not just how it looks on radar. Its strength is how quickly it can understand the radar environment, share that picture with friendly units, stay silent when needed, and adapt its mission software for the next fight. So the real revolution is not that Gripen replaces stealth. The real revolution is that it challenges the idea that stealth alone is enough. In Ukraine's kind of war, where every drone, radar, jammer, missile battery, and command post is part of one giant nervous system, the aircraft may not be the one that disappears completely. It may be the one that listens better, emits less, updates faster, and turns scattered battlefield signals into a kill chain before the enemy can react. That is why the Gripen CDL8 concept matters. It represents a shift from aircraft as a single weapon to aircraft as a moving brain inside a joint multi-domain network. And in the skies over Ukraine, that may be the difference between being invisible for a moment and being survivable for the entire war.
Link 16 has been the backbone of NATO air warfare for years. It is secure, battle-tested, and still extremely important because it allows aircraft, ships, ground units, missile defense systems, and command centers to exchange real-time tactical data.
But Link 16 was designed for an earlier era of coalition warfare, not for a battlefield where every signal is hunted, every transmission is mapped, and every second of delay can expose a launcher, a radar, or a fighter aircraft to enemy fire. BAE Systems describes Link 16 as a NATO and coalition standard for real-time tactical data exchange, with TDMA networking, secure voice, jam resistance, and improved situational awareness. That makes it powerful, but it also makes it widely known, widely studied, and heavily targeted in modern electronic warfare. This is where the CDL8 concept becomes revolutionary. Its value is not simply that it replaces Link 16. That would be the wrong way to see it. Its real strength is that it works as a tighter, faster, more mission-specific combat layer above the older network. Link 16 gives the coalition a shared language. CDL8 gives the strike package a private nervous system. In a high-interference environment where Russia is trying to jam, spoof, geolocate, and overload every signal, a Gripen-style link would prioritize low-emission behavior, faster sensor sharing, compact data bursts, and tactical silence. One aircraft can briefly sense, another can remain passive, a third can receive the picture without lighting itself up. This is not just communication. This is electromagnetic discipline turned into doctrine. For Ukraine, that difference matters because the country is not fighting with one clean, uniform arsenal. It is fighting with a battlefield mixture: Soviet-era S-300s and books, Western Patriots and Iris-T systems, mobile radars, drones, acoustic sensors, artillery networks, satellite intelligence, and frontline soldiers feeding data into digital command systems.
Ukraine's Ministry of Defense says its Delta system now supports real-time battlefield awareness, operational planning, and information sharing across units and with allies when needed. That shows the direction of the war. The winner is not always the force with the most expensive platform, but the force that connects sensors and shooters faster. So when we talk about Ukraine integrating Soviet-era SAMs with Western airborne sensors, the real breakthrough is not that one jet magically controls every missile battery. The breakthrough is translation. A Gripen-like CDL8 architecture would act as a bridge between different generations of war: old radars feeding partial tracks, drones confirming movement, Western sensors refining the picture, and command systems pushing that information toward the right launcher at the right moment. SIPA's 2026 analysis describes Ukraine's Delta battlefield system as a digitized model that fuses radar, human observers, drones, and other sources into near real-time awareness. That is exactly the kind of software-defined battlefield where a Gripen-style tactical link becomes far more than a radio. It becomes a combat translator. But the most important part is sovereignty. In the old model, the foreign platform comes with foreign software, foreign update chains, foreign encryption rules, and sometimes foreign control over what can be changed and when. In Ukraine's war, that is a serious limitation. Threat libraries change quickly, Russian jammers change quickly, drone signatures change quickly, missile routes change quickly. If every critical update has to wait for a foreign original equipment manufacturer, the battlefield moves faster than the paperwork. The CDL8 idea flips that logic. Ukraine would not just receive data, Ukraine would own the logic of its own battlefield, its own encryption keys, its own target libraries, its own electronic order of battle, its own rules for who sees what, when, and under what conditions. That is not just a technical upgrade, that is military independence in software form. Reuters reported that Ukraine sees its wartime data trove as a strategic asset and is being careful about how it shares that data with allies. That point is central. Battlefield data is no longer just intelligence, it is power. And this is why the Swedish Gripen concept hits differently. It does not promise victory through stealth alone, it promises survival through adaptation. In a war where the air is full of jamming, deception, drones, radars, and missiles, the decisive question is no longer only who has the best aircraft. The real question is who owns the network. Because the side that owns the network owns the tempo. The side that owns the tempo controls the kill chain, and the side that controls the kill chain can turn scattered Soviet-era systems, Western sensors, and Ukrainian battlefield data into one synchronized multi-domain doctrine. That is the CDL8 breakthrough. Not a louder radio, not a simple upgrade,
a new command architecture where Gripen becomes the airborne gateway between old weapons, new sensors, and sovereign Ukrainian decision-making. The real power of the CDL8 concept is not that it gives Ukraine another aircraft, it gives Ukraine another command node in the sky. In the old model, a fighter pilot flies, sees a threat, talks over radio, waits for confirmation, and then the information moves through a chain of human voices. But in a unified battle space, that chain becomes digital. A Gripen does not need to shout instructions across the airwaves. It can collect, filter, and transmit target tracks as data, clean, compressed, encrypted, and instantly usable by other units. This is how every Gripen becomes more than a fighter. It becomes a moving sensor, a silent scout, a relay station, and a battlefield coordinator. One Gripen can detect a Russian radar, another can stay passive and receive the track. A drone unit can confirm movement on the ground. A command post can validate the target. Then a HIMARS battery, artillery unit, or air defense launcher can receive the coordinates without a long voice conversation exposing the network. The pilot is not personally controlling HIMARS like a video game. The pilot is feeding the kill chain. And in modern war, feeding the kill chain faster can be more decisive than firing the weapon yourself. Ukraine is already moving in this direction. Its Delta battlefield system is designed to build real-time situational awareness, support operational planning, and share battlefield information across units. CIPA's 2026 analysis described Delta as a system that fuses drones, radar, human observers, and other sources into a battlefield picture. That matters because a CDL8-style Gripen link would not replace Ukraine's digital command systems. It would strengthen them from the air, adding speed, altitude, sensor reach, and electronic warfare awareness to the same unified picture. This is sensor-to-shooter compression. In simple words, the time between I see the target and the target is being engaged becomes shorter. A Russian launcher that once had 10 minutes to hide may now have 2. A radar that once emitted safely from behind the front line may now be detected, classified, shared, and targeted before it can shut down. A drone swarm does not need every instruction spoken by a human operator. It needs updated target data, safe corridors, threat warnings, and mission priorities. The Gripen cockpit becomes the place where this chaos is turned into a usable decision. But the most dramatic shift is the pilot's role. The pilot is no longer just flying an aircraft. The pilot becomes a tactical network manager inside a multi-domain theater. Saab highlights Gripen's wide area display, sensor fusion, and human-machine collaboration as tools that help pilots process complex mission data and coordinate weapons with the tactical air unit. That is the key. The pilot is not buried under raw information. The system filters the battlefield, highlights what matters, and presents choices fast enough for combat. This is why high bandwidth sharing matters. A traditional radio call gives one message at a time. A modern data link can share tracks, locations, threat warnings, identification data, and mission updates across multiple platforms. Link 16 already provides secure, jam-resistant tactical data exchange across NATO and coalition forces, and BAE describes it as a standard system for real-time tactical data between network participants. But the battlefield in Ukraine is showing that networks must become faster, quieter, more flexible, and harder to locate. That is where CDL8 as a concept becomes a battlefield weapon. It would not simply talk louder through Russian jamming, it would behave smarter. Shorter transmissions, adaptive routing, directional sharing, frequency agility, burst data, passive receiving, multiple nodes passing the same picture without every platform exposing itself. Link 16 itself uses frequency hopping patterns to improve resistance to jamming and exploitation, according to U.S. Joint Chiefs of Staff documentation. But the next step is building a network that can operate with even more discipline in a drone and EW-saturated war. For Russia, this creates a nightmare. Jamming one signal is difficult. Jamming a moving web is much harder. If a Russian EW unit blocks one channel, the network shifts. If it detects one transmitter, another node stays silent and receives. If it tries to blind one sensor, the battle space still has drones, passive sensors, airborne radar, ground observers, and command systems feeding the same picture. The target is no longer facing one weapon, it is facing an ecosystem. That is what it means to weaponize the unified battle space. HIMARS becomes more dangerous because it receives cleaner targeting. Drones become more dangerous because they operate with better awareness. Air defenses become more dangerous because they see beyond their own radar horizon. And the Gripen becomes more dangerous because it doesn't fight alone. It turns the entire network into its weapon. In Ukraine's war, the aircraft that wins may not be the aircraft with the loudest engine or the biggest missile load. It may be the aircraft that can connect every sensor, every shooter, and every decision point before the enemy understands what is happening. That is the CDL8 vision. Not a fighter jet acting as a lone hunter, but a Gripen acting as the airborne nervous system of a multi-domain kill chain.
Modern air war has a hidden weakness. It is not always the aircraft, it is the system behind the aircraft. For decades, Western air doctrine was built around powerful centralized planning, large air bases, controlled mission packages, and carefully synchronized command structures. That model works when communications are stable, runways are secure, and the enemy cannot constantly strike your logistics chain. But Ukraine is not fighting that kind of war. Ukraine is fighting a war where air bases can be watched by satellites, runways can be hit by missiles, and command posts can be hunted by drones. In this environment, rigidity becomes dangerous. To be fair, Western doctrine is not completely rigid. The US Air Force's own agile combat employment concept now pushes centralized command, distributed control, and decentralized execution, because modern bases are no longer safe sanctuaries. But Ukraine needs this idea at an even more brutal speed. It does not need a perfect air campaign built on comfortable assumptions. It needs aircraft, missiles, drones, radars, and ground units that can move, survive, reconnect, and keep fighting after the first strike lands. This is where Gripen's Swedish DNA becomes dangerous. Sweden designed Gripen for a country that always understood one cold reality. In a real war, your main air bases may be the first targets. That is why Gripen was built around dispersed operations, concealed wartime bases, small support sites, and even road strips on civilian highways. Saab states that Sweden has operated a network of dispersed air bases for decades, from concealed wartime sites to road strip operations on highways. Now imagine that doctrine inside Ukraine. A Gripen lands on a highway strip. The aircraft is refueled and rearmed by a small ground team. Its physical airbase is temporary, hidden, and mobile. But through a CDL8 style network, its digital airbase is still alive. Mission data, threat libraries, radar tracks, drone feeds, SAM locations, HIMARS target updates, and air defense warnings can move through the network even if the aircraft is not sitting at a traditional base. This is the idea of a virtual airbase. The runway can change, the hangar can disappear, but the command picture follows the aircraft. This is not science fiction. Saab says Gripen C can refuel and rearm in less than 10 minutes for air-to-air missions, less than 20 minutes for air-to-ground missions, and operate with minimal personnel and ground support equipment from narrow road-like runways. Saab also says an air-to-air turnaround can be done with 1 technician and 5 conscript mechanics.
For Ukraine, that is not just convenient, it is survival. A traditional airbase is a fixed target. A dispersed Gripen network becomes a moving problem. Russia can strike a runway, but it cannot easily destroy a doctrine. It can hit a hangar, but it cannot easily erase a distributed network of aircraft, road bases, mobile support crews, drones, and digital command nodes. And if the CDL8 concept allows each Gripen to reconnect with Ukraine's wider battle space from wherever it lands, then Ukraine does not need one perfect airbase. It needs many temporary launch points connected by one living digital nervous system. This also changes the cost-to-kill equation. Stealth aircraft can be extremely powerful, but they are expensive to buy, expensive to sustain, and dependent on highly controlled maintenance ecosystems. GAO has repeatedly warned that F-35 sustainment costs remain a major challenge, and Reuters reported that US F-35 availability in 2024 averaged only about 50%, below the Pentagon's minimum performance requirement, due to maintenance issues. Gripen's argument is different. It does not say, forget stealth. It says, do not make stealth the only path to survival. If survival can also come from mobility, electronic warfare, software updates, silent networking, frequency agility, and dispersed operations, then every dollar does not have to be locked into exotic coatings and centralized maintenance pipelines. Some of that combat advantage can be created through code, tactics, and network behavior. And in Ukraine, that matters because war is not only about the best weapon, it is about the weapon that can keep fighting after the enemy adapts. Russia changes jamming patterns, Ukraine updates software. Russia targets an airbase,
Gripen moves to a road strip. Russia hunts a radar. The network pulls data from drones, passive sensors, and another aircraft. This is tactical independence, not waiting for perfect conditions, not depending on one runway, not relying on one foreign update chain, and not freezing because the original plan has collapsed. That is the end of rigidity. Gripen's real value in this doctrine is not just speed, range, or missiles. It is the ability to turn a broken battlefield into a flexible system. Every road can become a runway. Every Gripen can become a node. Every mission file can become a new adaptation. And every Russian attempt to impose chaos can be answered by a Ukrainian network that bends, moves, and strikes back. In the old air power model, the base was the center of the war. In the Gripen CDL8 model, the network becomes the base. And once the network becomes the base, Ukraine no longer has to defend a single place to keep its air power alive. It only has to keep the system moving.
If Gripen proves itself in Ukraine, the shock will not stay inside Ukraine. It will travel across every defense ministry in Europe, Asia, and the wider NATO world. Because the lesson will be bigger than one Swedish fighter. The lesson will be that the future of air power is no longer decided only by radar cross-section, engine thrust, or weapons load. It is decided by how fast an aircraft can update, connect, adapt, and survive inside a digital battlespace. For years, global procurement followed a simple logic. Buy the most advanced platform, lock it into a long sustainment chain, and keep upgrading it through large, expensive modernization blocks. But Ukraine's war has punished slow systems. It has rewarded anything that can be modified quickly, dispersed quickly, and connected quickly. Saab openly presents Gripen E as a fighter built around revolutionary avionics, sensor fusion, electronic warfare, real-time data sharing, and software updates that can be made rapidly. That is why Gripen becomes more than an aircraft in this story. It becomes a procurement argument. This is the shift now pressuring global defense buyers. Countries do not just want a fighter jet, they want control over the fighter's evolution. They want modular avionics, they want open architecture, they want the ability to integrate local weapons, local sensors, local electronic warfare tools, and national mission data without waiting years for a foreign approval chain. Saab says Gripen's open architecture allows operators to control design changes and modify or replace parts of the system with minimal impact. That is the opposite of a black box model. It is a fighter designed to keep changing after delivery. And this is not just a Swedish idea anymore. Even the United States is moving in the same direction. The US Air Force recently described its own open architecture autonomy approach as a way to prevent vendor lock and allow rapid onboarding of new software and algorithms from different industry partners. The US Department of Defense also defines modular open systems approach as a strategy for affordable acquisition and sustainment over a system's lifecycle. In simple words, the world's biggest military customer is admitting the same thing. Closed, rigid systems are becoming too slow for modern war. This is where Gripen's potential Ukrainian role becomes strategically explosive. Ukraine is not asking for ceremonial air power. Ukraine needs aircraft that can operate from damaged infrastructure, connect with mixed Soviet and Western systems, survive Russian electronic warfare, and keep improving as the threat changes. Sweden's October 2025 letter of intent described a possible massive Gripen deal for Ukraine, while Reuters reported that Sweden was exploring ways to help finance up to 150 Gripen E fighters through aid, export credits, frozen Russian assets, and other support mechanisms.
If that path works, other countries will watch closely. Smaller and mid-sized air forces will ask a hard question. Why spend everything on a platform we cannot fully control when we can buy a fighter that gives us more freedom to update, integrate, disperse, and localize? That does not mean stealth aircraft disappear. It means stealth becomes only one part of the calculation. The new calculation is survivability plus adaptability plus sovereignty. And sovereignty is the heart of this story. For decades, the military-industrial complex offered countries powerful weapons, but often with hidden dependency.
The buyer received the jet, but not always the keys to its deepest software logic. The buyer received the sensor, but not always full control over the data architecture. The buyer received the upgrade, but only when the supplier was ready to approve it. That model made sense in a slower era. But in Ukraine's kind of war, where drones evolve every month and jamming patterns change every week, dependency can become a battlefield weakness. Reclaiming technological sovereignty does not mean rejecting allies or rejecting industry. That would be unrealistic. Modern defense is too complex for any one country to build everything alone. But it does mean changing the relationship. The customer can no longer be just a passive buyer. The customer must become a co-owner of the mission system, the data library, the encryption chain, and the upgrade path. That is the real revolution behind Gripen's appeal. It offers a model where the aircraft is not frozen at purchase. It becomes a living national capability. The F-35 shows the other side of this debate. It remains one of the most advanced combat aircraft ever built, but its modernization path has faced major cost and schedule pressure. The U.S. Government Accountability Office reported in 2025 that F-35 Block 4 modernization was over $6 billion above original estimates and at least 5 years later than planned. That does not make the aircraft useless. It proves how difficult closed, highly complex upgrade ecosystems can become when software and hardware modernization are deeply tied together. This is why the future may not belong to the prettiest airframe. It may belong to the fastest learning network. The aircraft that wins peer-to-peer warfare may not be the one that looks most futuristic in a hangar. It may be the one that can land on a road, upload a new threat library, connect with drones, feed targeting data to artillery, receive passive radar tracks, and return to the fight before the enemy even understands how the system changed. That is the final meaning of the Gripen CDL8 concept. It is not just about Sweden. It is not just about Ukraine. It is about a global shift from platform worship to network dominance. The airframe still matters, speed still matters, weapons still matter. But in the next war, the decisive weapon may be the architecture connecting them all. The future battlefield will not ask which jet is the most expensive. It will ask which force can adapt faster. It will ask who owns the data. It will ask who controls the software. And most importantly, it will ask who can turn every sensor, every shooter, and every aircraft into one living combat system. That is why Gripen matters, because it points toward a world where the network, not the airframe, dictates the outcome of peer-to-peer warfare. And if Ukraine becomes the testing ground for that doctrine, then Sweden will not simply be exporting a fighter jet, it will be exporting a new blueprint for global defense. Thanks for watching to my channel. Like, subscribe for more new updates.